Okay. All right. So we're going to be starting on circles, arcs, central angles, and things like that. So we're going to be doing some note taking, and we'll be answering some questions, and then you guys can start by looking at some homework. Okay. I'm going to be tearing this off and adding new ones every time. But as you look over here, you all have your notebooks out?
Yeah. And I printed out the notes.
What's that, huh?
I printed out the notes.
Oh, great. Okay. So the center point is always how we name a circle. So whoever that is, so this would be circle B. If I drew another cute little circle over here, this would be the name of the circle, would be circle C. Is everybody all right with that?
Mm-hmm.
Okay. Now, if I go ahead and I cut the circle in half, what is that segment called?
The diameter.
Diameter, thank you. So we can basically say a diameter. That's the circle in half. Okay, that's literally what a diameter does. It cuts a circle in half. So, and that means, and it has to pass through what point?
The center point.
Thank you. Sienna, is that you?
Yeah.
Is it going to be the Sienna and Seashwa show? Like everybody else is just going to sit back and can you interject when you know something? I would love that, I mean, I know that we're all in different locations, but we're together, all right? So yeah, diameter cuts the circle in half, and it has to pass through the center point. And a radius is how much of a diameter?
Half.
Half. And it always comes from where?
Like the midpoint to the outer.
We don't use the word midpoint in a circle. We're actually going to use the pretty word called
Center.
The center point. Okay. So
Okay.
we're going to say that the radius, yes, is half the diameter. And comes, oops, that's an F, from the center. How many radii are in a circle?
Infinite.
Good. How many diameters are in a circle? Let me tilt this down so you can actually
Infinite.
infinitely many. So in other words, there's infinitely many like diameters and radii in a circle, because if you think about it, imagine that this right here is where my center is. And if I spin all the way around, I can make up infinitely many segments as I go around in a circle. Okay. And we've talked about circles before, so it's not as if this is a new thing for us. Okay. So get ready. I'm going to put up a new one. Move in here.
Lucas should be joining us too.
I have stuff all over the floor. Ooh, okay, so next one going up. Okay. A chord. A chord. Does anybody know what a chord is, or wants to take a crack at what a chord is?
I know what a chord is.
Who said it?
Segment whose endpoints lie in the circle. So there's infinite.
Right. So a chord is a segment
No.
that connects. Can you see that? By the way, if you can't see something, let me know, okay?
Got it.
Point on a circle. All right, so it is a segment that connects any 2 points on a circle. So I want you guys then, right now, and I'm going to take off my present. I'm going to ask you guys to sketch what you think a chord looks like, and then grab your notebooks and hold it up. Okay, so while I'm drawing my pretty little circle, you guys go ahead and draw what you think a chord would look like. And I'm going to get out of present for a second, because I want to see what you knuckleheads come up with. This is awesome.
Hey, Lucas.
All right.
Hi, Lucas.
All right, so let's see. I'll get onto myself. Okay. So Bradley, I can't see yours because you have no picture, right?
Yeah, can I just not use the camera? I chipped my tooth,
Yeah, that's okay. It's fine.
so it's like not good.
Harrison, you have your. Let me see. Connor, well, move it further away because I can't see.
I have an idea.
You had it right up against it. I couldn't see it. Is that a Darth Vader chair? That's very nice. Can you draw one that doesn't have to pass through the center?
I think so.
Just connect any 2 points on the circle. So let me see, Sienna, hold it up a little bit better. That is a nice looking chord. Good. So Sienna, just talk, Sienna, so we can see yours again.
Hello.
Beautiful. Also, Rachel, let me see you. Beautiful. Okay. Everybody say that's very nice. That looks very nice. Rachel, that is not a chord.
Mine, yeah,
That's more like a central angle. A chord has to go from one point on a circle to another point on a circle. So just pick 2 points on a circle and then just connect them with a segment. That's literally what it is. So just anywhere you want. There's a chord. Atta girl. Good. So that's what a chord looks like. So I'm going to go back to present. So I love that. Isn't that nice? Don't you love how I hold you guys all accountable and stuff? It's wonderful. I'm going to go over my name here. I'm going to go back to, come on.
Oh.
Going over my face. Oh, good morning. Thanks for coming. All right, now I'm having an issue with pulling this up. Is this really happening now? So I want to go back to present and, oh, here I am. Okay. Oh, I think, oh my God, I think I just got a marker on my face. Hold on a second. All right, I'm waiting for that little pop-up to come up, and then we'll go from there. Okay. Who is the longest chord on a circle, by the way?
The diameter.
The diameter is the longest chord, exactly. So you can actually say the longest chord is the diameter, and I don't understand. Oh, here we go. Oh, yes, all right, I'm back. All right, and so in my entire screen, so I will be back now. And give me a second here. Boom, and boom. So you should all have me and present. Yes?
Yes.
Lucas, if I'm backwards, just pin, what did you guys say, pin yourselves or pin me?
Pin you on the right side. Click the pin button.
Okay.
Yeah, it goes around, okay? So this is consistent.
Awesome.
So we can say like CK. CK is a chord. Okay, we can say B. BT is a chord. And we said that the longest chord is the diameter. Okay, the longest chord is actually a diameter, which is very nice. Okay, so then I want to get into central angles and arcs, and actually, Rachel, you accidentally happened upon that. Isn't that nice? Okay, you should smile and laugh. This is interactive. Central angles and arcs is the next thing. So if I said to you guys, a central angle, where do you think the vertex of the angle would be?
The
Say
center.
central angle.
The center.
The center, exactly. So if I go ahead, I need a 3-letter word.
Dog.
Okay, dog it is.
Yes.
First of all, what's the name of the circle? What's the name of the circle?
Oh.
Circle O. So this is circle O, and then we say the central angle is angle dog. Okay? All right? Central angle, it has its vertex at the center.
Can you angle the camera down a little bit more?
Made up of. Like if I said to you that angle, this angle here, what is it made up of? Two what?
EOG.
Radius.
Oh.
Two radii. Very good. Okay. It's created.
Can you angle the camera down?
Yes.
Thank you.
Is that better?
Yeah.
Okay. It's created by 2 radii. Awesome. Okay. So that is what a central angle is. A central angle is an angle whose vertex is at the center and it's created by 2 radii. I have to send a thank you to Mrs. Mahaffey because she's the one who gave me all this poster paper. Okay. Can I take that one down?
Hold on.
Am I holding on?
Yes, please.
Well, this doesn't feel like it has any adhesive. There's no adhesive on that one, so bear with me. Go to this one. It's very strange. All right, I'll have to go get tape. Bear with me. Okay. I need to install a whiteboard over here. What do you guys think?
Yeah.
That'd be awesome. That'd be really cool. Just put that right there. This is my makeshift way of making a board. So this is what you do on the fly. Okay, so we know what a central angle is. Now, how many degrees? Let me tilt this back up. Can everybody see the top now?
Yes.
Yeah.
How many degrees are in a circle?
360.
16.
Who said that?
Nick
Who
did.
was the knucklehead who said that? Degrees in a circle is 360. Okay. Knucklehead. All right. If we were in school, I would be making giant size circles to show you how fabulous they are. All right. So, okay. And then we're gonna go C, U, C, A, S. The bucks stop here. So while you guys are copying that down, I'm going to ask you a lot of questions about it, okay? All right. Okay, let's name some radii. Just shout out the radii.
SU.
SC,
SC.
The radius.
SB.
Okay. Let's name the radius.
S
S
B.
and SC. What's the, is the diameter?
Yeah.
Yeah,
C,
because I
B.
should be calling this, I should be saying that this is circle, the name of the circle?
S.
Circle S. So now that I've named it circle S, I now know that I'm going to ask you for a central angle. Can you give me an example of a central angle? Anyone? Anyone?
K S
S what?
C.
Wait, can you give me another angle? Central angle. C is one of them. I didn't hear that.
BSA.
oh, BSU,
BSU, very good. BSU. Lucas, did I hear you? Lucas, you have one?
SB. Oh wait, we did. Yeah, KSB. That's one. Right.
How about USC? Is USC a central angle?
Yes.
Oh, yeah.
The USC is. How about
USC.
ASC? We said that. How about did we say USC? Yes, we did. BSU. We can also say BSK. Is everybody okay with that? BSK. All right.
Wait,
Now, what about
BSC?
BS? Are you guys okay?
Is BSC an angle?
BS.
C.
Yes, I didn't hear you. Who? Yeah,
BSC.
BSC. Yes, BSC. What's the measure of that angle? Angle BSC.
180.
What's the measure of that angle?
180.
180. Good. Yeah, it's a straight angle.
Oh.
Now, let's say I made this 100 degrees and I made this 88 degrees. Could you tell me what the measures of the other central angles are?
Yeah.
Sure.
You know.
What would you say angle SC is? Who else is in this little party that I haven't talked to?
80. Oh,
Yeah,
God.
USC.
Connor, how much is angle USC is 80? Very good. And then Harrison, how much would angle CSK be?
CSK.
CSK, because the relationship between these two angles is add up to how much, kiddo?
180?
Yeah. So that means 88, blah, 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 blah. And they should be
92.
92 degrees. Very good. Now, central angles go out and they intersect arcs. So if I said to you, what is the arc that is being intercepted by angle BSU. If I have angle BSU and I swing my arm around, who's the arc that he's intercepting?
BU.
BU, very good. It would be BU, okay? And that would be the answer to that would be arc BU. And we put a little arc symbol over that to show that we're talking about the actual arc. When I say arc BU, I'm talking about this part of the circle. So there's a curve along here that I'm actually following along with, okay? Anybody else can tell me if I said angle USC? Angle USC, what is the arc that he is intercepting? So again, here's arc USC. Can you all see what I'm doing? And if I say the arc that he's intercepting would be?
CU.
CU or C, either way. And again, you put that little arc symbol over there. And then if I said angle CSK, what is the arc that he is intercepting? Arc angle CSK. Somebody can shout it out. There's angle CSK.
okay,
DK.
CK.
What did you say? CSK
CK.
will be CK. Very good. And then finally, if I did angle BSK? Angle BSK would be
BK.
BK. Now, the measure of its central angle and its arc are the same. Put that somewhere. The measure of a central angle are equal. So if I said to you then, what's the measure of arc BU?
100 degrees.
So you guys are you guys furiously writing down what I'm writing up here? Look at you guys.
Yeah.
So the measure of a central angle and its arc are going to be equal to each other. So that means that if angle BSU is 100 degrees, then the measure of arc BU is
100.
100.
100 degrees. And we write that out. We would put the little M symbol like we would do with our angles, and we say the measure of arc BU is 100 degrees. Can you all see that?
Mm-hmm.
Okay. If I asked you guys for the measure of arc UC, what would be the measure of arc UC?
80.
80 degrees. Very good. And then if I'm going to keep filling these in. Okay. Is equal to, and then the measure of arc CK. Equal to. What's the measure of arc BK?
88.
88 degrees. Very good. And then the measure of arc, that's 88 degrees. And then what's the measure of arc CK?
92.
92 degrees. Now, I'm going to get crazy. I'm going to go with a new color. Look at me go. Okay. This is one of my favorite colors. This is a really pretty color. What if guys, can you see over here? Can you guys see where I'm writing?
Yes.
What if I said the measure of
Yeah.
arc cub? What if I wanted the measure of arc cub? What would be the measure of that arc? Cub, all the way around the circle, what would you all say?
180.
180, very good. What if I said the measure of arc UBK? What if I said the measure of arc UBK?
188.
Would be 180 because you're starting at U, you're swinging around to B and going around to K, and that would be 180 degrees. And then what if I did, I'm gonna get crazy. What if I said the measure of arc CKU? I'll wait for you guys to do that one. The measure of arc CKU.
Would that be
Oh, get your calculators out, little friends. The measure of arc CKU.
280?
30.
280 degrees. Where did we get 280 degrees from? Oh, by the way, this
92, 88, 100.
right. So, so this would be three. What did we say it was? 280.
Yes.
So that's going to be 280 because if I'm saying measure of arc CKU, I have to start at C. I have to pass K, and then I have to go all the way around to U. So it's everything but that 80-degree angle, 80-degree arc. Yes. So because of that, you could have done it two ways. You could have added 92, 88, and 100 up, or you could have done
360 minus 80.
you could have done 360 minus 80 to get 280. Is everybody all right with that?
Yeah.
Okay. All right, here comes the next one. All right. I love geometry loves me. All right. Okay. Next. Okay. All right. Did you guys see that?
Yeah.
Who's making all that clicking noise? There's all they're made for clicking. Quiet. Okay. Can you guys see all the problems? And I'm going to call this circle D. All right, so we got ourselves circle D. So I want you guys to answer those questions for me. How we doing? Okay. Like that. You tell me what the measure of angle. I already know what the measure of angle FDU is. How about FD? We know that FDU is 70, right? Everybody with me?
Yeah.
Okay. What does that make FDG? What does that make
110.
FDG? This guy right here.
110.
110.
It's going to be 110. Now, can I ask you what kind of triangle is FDG?
Isosceles.
It's isosceles. So whoever
yeah.
shouted out isosceles, how do you know that that's an isosceles triangle?
Because
Oh, because the radius.
because all radiuses are equal.
All radii are congruent. So whenever you do that, so for you guys, make it a good habit to mark all your radii equal to each other. You've got yourself this delicious isosceles triangle. So then these two, what angles are these called again? It's an isosceles triangle?
The base angles,
Those are
right?
base angles. So we can find the two base angles because we can do 180 minus 110, which gives us 70, and half of that is?
35.
So these are each going to be 35 degrees. Yes? So FD, we already knew was 70. That was okay. I didn't mean to write it like that. And we now know that DFG is 35 degrees. What's the measure of arc FU? That's not very nice. What's the measure of arc FU? Somebody shout it out.
70.
70 degrees. And then what's the measure of arc FG?
110.
110.
Oh my god.
Arc GU. What's the measure of arc GU?
180.
180 down here. Good. So that's going to be 180 degrees. So if I say GFU, so GFU is also how much?
180.
180.
180. But then I asked you guys for GUF. You see how that's a different one because it's going in the opposite direction, if you will?
Mm.
Does everybody see? If I say GUF, you have to start at G. You have to pass through U before you get to F.
Yeah.
Is everybody okay
Yeah.
with that? Good. And that's going to be
250.
250.
Okay. All right. Now, we have things called minor arcs, major arcs, and semi-arcs. We have those three right there: major arc, minor arc, semi-arc. Okay. If I said to you semi-arc is synonymous with semicircle, what would you say in this example would be a semi-arc? If it's a semicircle, how many degrees do you think a semi-arc would be?
180.
180 degrees. So it is an arc that measures exactly 180 degrees. So if that's what a semi-arc is, what do you think a minor arc is?
Anything below 180.
It's got to be below 180 exactly, but it's got to be greater than how much?
0.
Good. So a minor arc is between 0 and 180 degrees. Okay? So that means it's going to be between 0 and 180. This should be less than 180. So what do you think a major arc is?
Above 90. And
Oh,
below.
careful, because it's a semi-arc. We already know a semi-arc is 180, right? So that's the
Oh.
baseline. So we know that a minor arc is anything smaller than that. So that means a major arc has to be
Greater than 180.
and less than. Less than. What does it have to be less than, everybody?
360.
360.
It's got to be less than 360. So that's going to be 180, between 180 and 360. So in this case, if I asked you guys to name me a couple of minor arcs in this example, who would be some minor arcs in our example here in this diagram?
RQF.
RQF. So in other words, we could say RQF is a minor arc. What is another minor arc?
FG.
FG is another minor arc. Very good. If I ask you for a semi-arc, who would be a semi-arc here?
UG.
UG.
Or UG, yes, you can say UG. That would be your bottom arc, and then your top arc you could also say is arc U. That top arc. So in other words, UG would just be the bottom guy, but when I say UFG, it's that top semi arc. What's a major arc? Can you guys name a major arc for me?
GUF.
What'd you say? GUF?
Yeah.
Okay, so that would be arc GUF. Mm-hmm. By GUF, can we name another major arc? So we did G, we went around to U and over to F for our major. Is there another major we can do?
FGU.
FGU, very good. Aren't they different measurements?
Yep.
GU. Okay. Oh, hi, Doodles. Did you guys see my video? Did you see Doodlebug? Come here.
Yeah.
He's wondering, there's papers all over the floor, and he's like, what is going on right now? But he's so cute. Okay. You guys have that all written down?
Yeah.
So then we're going to do this. What do you think, Bug? All right, I have that one. So we have circle H here. And I want to say one more thing. 5, 6. Angle EHS. Okay. So we have this diagram here. You don't have to copy this down. You can watch this later. I'd rather you do this with me because I want to kind of speed things up here and kind of call it a day. All right. So here we have circle H. And I told you that EH is bisecting angle PHS. What do you know? What do you know? If EH is bisecting angle PHS, what's going to be congruent?
PHE and EHS.
So this angle here is going to be congruent to that angle there. Now, do we have enough information to complete this diagram?
Yes.
Yeah.
Yes, we do.
Yeah.
Because what can I call OS?
Narrative.
What's OS called? Segment OS is a what?
Semi.
It's a diameter. What else is? Who else is a diameter in this figure?
PK.
Okay.
Okay, very good.
Well,
So
PK.
if this is 86 degrees. First of all, can I find out OHK?
Yeah.
Sure. What's the measure of OHK?
90.
Well, this is 86
Well,
degrees. How could that
Oh,
be?
it would be 94.
94 degrees. Very good. So if this is 86 degrees, who else is going to be 86 degrees? Shout the angle out, someone?
SHK.
Yeah, and that's how many degrees?
86.
Say 86. Bravo. And then over here, I can find out what the measures of these two angles are because they're going to be half of 94. We all are right with that.
Mhm.
Okay. So what's half of 94?
47.
47 degrees. Very good. Okay. Now, if I want to fill out the arcs, what's the measure of arc PO? Start yelling. What's the measure of arc PO?
86.
86. What's the measure of OK?
94.
94. What's the measure of SK?
86.
86. What's the measure of ES?
47.
47 degrees. And then we know PE is 47 degrees. What I want you to do now is I want you to name 5 minor arcs, 3 major arcs, and 2 semi-arcs. Go ahead. When you're ready, let me know if you can name them. I'm going to give you about 12 seconds. Okay, 12 seconds. Minor arcs. Let's go. Rachel, give me a minor arc. Anything that's less than how many degrees?
90.
Anything
180.
180.
Any
180.
minor arc that anything that's less than
180.
180. So give me an arc less than 180 degrees.
OE.
PO.
Oh, what did you say?
OE.
OE is fine. Sure. Arc OE is fine. Another arc.
OP.
OP is great. Another minor arc.
Okay.
Okay is another minor. Go ahead.
Yes.
Yes is great. We all got the idea? Good.
Mhm.
Can I have a major arc, please? A major arc is anything that's greater than
180.
180. Let's go. Bradley?
Okay.
Okay.
Wait,
Not a minor
oh,
arc. I'm sorry, it's not a major arc. It's a minor arc, honey.
SK.
Can't you go all the way around though for OK?
Everybody, move on to major arcs.
I said SK.
SK. Very nice.
Okay.
SK is beautiful. Can I have another major arc? Lucas?
Oh, okay. Can you also do OEK too, or is that the same thing?
OEK. It's the same arc.
Yeah.
Yeah, so pick a different.
You do SPK.
SPK is very nice. SPK. Tiana, you got one?
KOP.
KOP. Actually, KOP would fall under what umbrella?
Semi.
Semi.
Semi-arc. So I could say KOP is a semi. I need a major.
KOE.
Okay, very nice. So arc KOE. Rachel, can I have another semi?
SO.
Give me 2 letters so I know which way you're going. Or 3 letters. Give me 3 so I know what direction you're headed in.
SKO.
SKO. So that's the bottom arc, right? And then you could say SEO, and that would tell me that it's the top semi-arc. Okay? All right. This should get you started on your homework. If you have to look up what a, let me get off the presenting now. If you might have to look up what inscribed angles are. That might be your job, okay?
Sichua.
Yeah.
Do we submit it to you? Or like, do we submit the homework to you? Like take a
Yeah,
picture?
the homework, what you're gonna do is you'll take pictures of it on your phone and then that folder. Did you create your share drive folder?
Oh, is that what we did on Friday?
Yes, on Friday we created the share drive. If you need me to resend it to you, I will. Or somebody request access. But any work that you do, you're gonna take pictures of and then upload them onto the share folder with your, because you have a folder with your name on it. So what I can do is do this now. So
Right, yeah. Can you send me that?
So what I can do is show you this. Hang on a second. So if I go to my Google Drive, just wait a minute. Well, I'm not on present anymore, am I?
No.
All right, so let me go back to present. Present now. So just show you that if I go to my entire screen, right, share along here, that if I go into here, into the my Google Drive, and in my shared drives, Connor, right? So I'm just waiting for this to clear onto my shared drive. If you look down here, there's a period 4 for you guys, and then under that, everybody's names, everybody will show, it'll show. I don't know why this is going so slowly, but it is. Come on, this year. Everybody's names are popping up in here. So you'll see that everybody's got their own folder that they created. So you'll create your own folder and then just upload any work that I have you guys do. Okay?
Oh, that's awesome.
We have to like take a picture of it and then.
Yeah. Okay. Yeah. Or if you want to be a savage and be like, I'll make a little video of it, that's fine with me too. So that's entirely possible what you guys, what you want to do. Okay?
Okay.
So I just want to know, do you guys have any questions?
Yeah, wait. So I'm looking at this homework.
Yeah.
This one, right? How do you can't like complete the circle? Like I don't know how to complete the circle for that one.
Where am I looking?
I mean, do you have the sheet?
No, hold it up for me now because I just unpinned it. Now you're frozen. It's great.
You like that?
No,
You
it's
know
just I don't know. I guess maybe I'm making a mistake here.
But hold it up. Let me see what it is. Are you trying to present?
No, I'm trying to like complete the
There?
circle so
Oh.
I can find all the angles.
What about? Well, you have isosceles triangles everywhere, brother. Right?
Yeah, and then wait, am I also gonna want to use like the sine, cosine, and tangent to find
No,
like?
do you see any right
No.
angles in there?
No.
No, me neither. All right.
Okay.
So go for
Awesome.
it and we'll
Okay.
revisit it. I mean, you know, we'll revisit. So if you have questions, bring your questions and we'll certainly go over
Mhm.
that. So,
Because I did the other sheet, like no problem. But like, and
Alright,
then I did the bottom one, so that's fine.
Mhm.
Yeah.
so
Okay.
that's why we do what we do. So, okay.
Cool. All
I'm
right.
going to
Bye.
unpin this. All right. Take care, everybody.
Bye.
There it is. I want to stop recording. This will be posted on Canvas, by the way, just so you know.
Okay.
All right. So have a good one. And this is stop recording.